Well, we're at the 2014 SAE Convergence, and here we are at the EconoCar 3 project. Remember, there was a 1 and there was a 2, and Amanda's with me now, and she's going to tell us a little bit about what's different with the EconoCar 3 project. Amanda.
Thank you. EcoCar 3 is sponsored by Department of Energy and General Motors. And as you can see, this is the third competition of EcoCar. We are in the first year. It's a 4-year competition. And this year, the 16 university teams across North America are in the first stage of the competition, which is modeling and simulation. So they're choosing their design this year. And at the end of the year, they're going to take that design and show it to a panel of judges. And then they will get an actual Camaro donated by General Motors, in which they will take the components out and put their own design back in.
Right, well, you heard what Amanda said. This year, if their design is approved, it's a Camaro. Wow, that's going to pose some unique challenges, right? Tell us about those.
Well, definitely, there will be some unique challenges. It's really exciting as well. The students are going to have to take, of course, the packaging is a bit different from previous competitions, so that will provide a challenge. The students the main goals of the competition are increasing the fuel efficiency as well as reducing greenhouse emissions. And so they will have to do all of that while maintaining consumer acceptability and hopefully increasing the performance of the vehicle as well.
Wow, so they're going to try to improve the efficiency of the vehicle and improve the performance. But there's one more challenge, isn't there?
Right. This year we are involving cost into the competition. So this is a vehicle that, if put into production, would need to make sure that they factor in the cost of actually manufacturing the vehicle.
Wow, now that's really a challenge, isn't it? They're going to improve the performance, they're going to improve the efficiency, and they have a budget they have to meet. Wow, just like the real world. Well, I hope these kids do well. They usually do, don't they? So we'll be looking at the Econo 3 project as it moves on. And now we're going to talk to some other college students about a different kind of a car project. Let's go visit them. All right, now here we have a slightly different project car, and this is the University of Michigan's solar car, and they're getting ready for a really special competition, right, guys?
Yep.
Ian, tell us about that.
Well, the big race that we're preparing for right now is the World Solar Challenge in Australia. It's going to be about a year from now in October of 2015, and that race starts in Darwin at the northern end of the continent, and then it's a sprint to the finish down in Adelaide through the Australian outback.
Well, tell us a little bit about what's different about this car than the last year's car.
This particular car is our 2011 model, which was a three-wheeler and hyper-aerodynamic. In 2013, they changed the regulations to require 4 wheels, which just was a huge game changer within the sport. And it's like cars just slowed down significantly. And looking forward into 2015, it's going to be another 4-wheeler, but now that we've designed one, we know where we can make some improvements on, and we also saw like what our competitors are doing, so that gave us some new ideas as well.
Yeah, so aerodynamics and propulsion and all kinds of things are going to change, right?
Yep.
Okay, and Neil, tell us a little bit about which is different mechanically and electrically this year.
Well, mechanically, we are moving, because of the 4-wheel design, we also have to change our entire suspension system to accommodate the 4 wheels. And also a few things in our chassis which need to be rearranged so we can still maintain a really sleek aerodynamic frame but still maintain a full rigid frame so that we can withstand all the loads. I'm sure Ian could probably fill you in more about the electrical components.
Yeah, and because of that, the speed has changed a little bit, right? You were telling me about the different speeds that were achieved because of the different designs. Let's go over that one more time. On the 2011 car, how fast did you have that one going?
This car theoretically could go up to like about 110, 120 miles per hour, but our tires are only rated to 80, so we can't really go above that. But this car has hit 80 miles per hour and sustained that for a while. 2013, just because of the 4-wheeler and less aerodynamic design, we were topping out at around 70 to 75. But looking forward into 2015, we're really pushing to be able to go as fast or faster than our 2011 car, and hoping like 80 or higher speeds.
Oh, that's still pretty respectable. Absolutely. Yeah. So, have you ever driven this car?
No, we have size requirements for our drivers, and I am both too big and both tall and wide for the car.
That's why I asked you. I didn't think it could fit into the thing. But
yeah.
Your brains are what's important right now,
yes.
right? Absolutely.
Yeah.
We've got to have that. But you've driven the car, right?
Yeah, I was a driver for the testing period of our 2013 car, and it's definitely less comfortable than commercial vehicles, just because you have a lot less legroom and you can't move around at all. But compared to by solar car standards, the 2013 car was pretty luxurious because it did have a little bit of open space, and the regulations required that you be able to move your head forward and backwards a little bit.
Yeah, well, I guess that's something, right? A
Yeah.
little bit of creature comfort in the solar car. All right, so that's the solar car from the University of Michigan. And Neil and Ian, thank you very much, and all the rest of the students participating in this project. And let's wish them all luck in Australia this year.